Hello guys, my name is Antonio Jimenez.
My name is Jovan Attisha.
And my name is Mulani. And this is our senior design project for EECS 467 at the University of Michigan. We designed a robotic arm to play air hockey against the human user. This video will show you how we got the project done.
This is our setup. We built a wooden stand to support an Xbox Kinect on top for puck detection. We also have our robotic arm mounted at the opposite end of the table from where the human plays.
To command the robot arm to defend its goal and attack the opponent's goal, we needed the location of the puck. To accomplish this task, we used libfreenect, an open source library to interface with the Xbox Kinect, and OpenCV, an open source computer vision platform. From its position above the air hockey table, the Kinect sends frames to our CPU. In our code, we set a series of parameters like the color range and the area of the object we wanted to detect, namely the puck. Then, whenever we receive a frame from the Kinect, the image is passed through a binary filter that converts the color range we're interested in, red, into white, and all the other colors into black. Next, using the contrast between black and white, OpenCV reports the coordinates of the blobs with the right dimensions, as set in our code initially. At slow speeds, the puck tracking works really well, but at relatively high speeds, the Kinect loses track of the puck. Unfortunately, its maximum frame rate is of 30 Hz, which limits the performance of our system. The next challenge was that the coordinates of the puck given by OpenCV are with respect to the Kinect's reference frame. We wanted the coordinates of the puck in the robotics arm reference frame. To complete this task, we used the green calibration markers you see near the corners of the arena. We measured their position with respect to both frames and solved for a transformation matrix that would translate from the camera's frame to the robotic arm's frame.
The Rex arm is a 4-degree of freedom robotic arm designed in the April lab at the University of Michigan. The Rex arm is composed of several 3D printed links with Dynamixel servos as the joints. The servos help to both control the Rex arm and report its current orientation. At the end of the Rex arm, we 3D printed 2 parts to position the striker and rotate it on the air hockey table. We implemented both forward and inverse kinematics for the Rex arm. Forward kinematics methods were mainly used for testing and debugging purposes. Inverse kinematics played a much more critical role in the project. We used the XY coordinates of the puck and the robot's reference frame to constantly calculate the puck's angular offset from the vertical axis. This allows the Rex arm to follow the puck at all times. We use inverse kinematics to calculate the necessary Rex arm joint configurations to place a striker in the desired position. When the puck is far away from the goal, the Rex arm moves along a radius close to the goal. Once the puck passes a distance threshold and gets closer to the goal, the Rex arm moves along a radius farther from the goal. The transition between the radii of motion is the striking action for the Rex arm. If the puck is within plus or minus 5 degrees of the vertical axis, the striker prepares to hit the puck head on. If the puck is outside of the range, the Rex arm still tracks the puck, but rotates the striker 45 degrees away from the tracking line. Once the puck approaches, the striker moves towards the puck and rotates into the line of the puck's motion to hit the puck as hard as possible towards the opposite goal. When the puck gets stuck behind the Rex arm, there is a feature implemented so that the Rex arm can detect this and stay far away from the goal so that it does not come back and knock the puck into its own goal. This feature is also useful for when the puck gets stuck against the wall. The Rex arm detects that the puck is stuck and moves away to let the puck return to the user. Additionally, when the puck goes out of sight, the Rex arm moves away from the goal, with the motivation being that when the puck gets stuck under the Rex arm, it moves out of the way and does not hit it back into its own goal.